Okay, so there's a little bit of an issue while we just set up to go live. Just bear with. Where's the webcam? Is that in view? Da, 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 da. Okay, we now have, should now have. Okay, that's the webcam set up. Okay, so now the webcam set up. Let's quickly see what we've got here. We don't want that enabled. We do want that. No. Okay, I know the quality isn't the best, however we're gonna just have to do that for now. As my computer is doing other stuff at the same time. We'll wait for a couple more. Oh no, that's still okay. So today I'm going to go through, do some live coding. If you've missed this stream, you'll be able to watch it on YouTube as well. So I'm doing this at 1 o'clock on Sunday. So here we have the code for the microcontroller currently. It's still in a lot of development stage. Point of a version. Last time it's been working, and that's what you saw in the Kickstarter video, and now I'm starting to work on a bit more of the bug fixes and more features which are easy for me to add in. I did have a attempt at I2C. I got some random characters to display on an I2C display, but that's about it. Otherwise, I2C weren't really the best yet. That is. So, bits which have changed since the last version, from what I remember, are spelling mistakes, which it don't want to fix. There we are. The serial baud rate has gone up to 3 million, up from the standard 115,200. I've been using this on the IC for a little while now, and everything seems to be testing out fine. If it tests out fine by the time the production boards are here, we'll go for that probably. I don't see why not. I was doing some debugging down here, as you can see, for I2C, but I've recommented that out, so then I can get some of the basic main important bits done. In the bottom, on this screen, the bottom right hand corner, I'm actually going to change it to the other side, as that makes sense to do. See, can I change it? Nope. Is a RTk.GPIO board with a traffic hat on top, which is really nice to be able to develop with quickly, so that's why there's a traffic hat. There we are, move that over here. Oh, so that's where it's all gone. Okay, let's move it that way a little. Let's just make it smaller. There we are. I've got a traffic hat, and as you can see, there's 4 cables coming out of the side of it. They lead to the programming board. These are, as it's a ST microcontroller development board, the top part cuts off the Nucleo boards and becomes a programmer. This is the bottom part for reference. So, currently the code mostly works, but I changed in Python what command sends for each GPIO pin. So, at the moment, GPIO 2 used to be sent as the letter C, because then if you had 0 and 1, the letter C would be number 2. I'm not planning on supporting 0 and 1 yet. If I can do it on the hardware, I might do on the software later, but for the moment I need to be able to get 2 working all the way to 27, so that's what's most important. I believe it's to 27, I'll have to double check that. Where's my ruler? See, GPIO 26, 21, 26, 27, I don't see a 28, which is good, I believe. Yep. Okay, so what it is that I'm gonna get GPIO 2 to 27 working, and then I might add 1 and 0 at a later date, so I'm gonna fix this bug. The Python library has already been updated to do this, so it will send the letter A if it wants GPIO 2 to turn on. We need to fix the microcontroller, so the microcontroller will then do GPIO 2 from the letter A. So if I go down here, I believe I started to do work on it, so I'm going to just add in some breakpoints. And it used to crash around here. If not, then this is handy to know. I'm going to then run the software on the debugger. The programming board will now program the RTk.GPIO. Oh, we have an error. Nope. 160. We have an error. Oh, we're debugging the wrong one. There we are. So it's now compiling it. It's compiled, and then what it will do is it then bring up the debugger, which we should get any second now. No, we have another error. Okay, so that's our error. What happens is, when you're developing the board, there are 3 pins which the board overlaps with. So I need to quickly go and check what pins it uses. PA14. So if I now go to embed, targets, pin names, yep, and we are looking for PA14, GPIO 13, and I believe with it IO6. GPIO 6 PA13 is, yep, so it's PA13 that needs commenting out as well. There we are. So now if I go to rerun it, and we have another error. Okay. What this usually means is you have to connect to the chip, erase it, and re-debug. Here we are. Yep, so that's all worked. So now if I click go, the program is running. I'm going to re-enable breakpoints. You can go. There we are. So the board is now waiting for my command. I'm going to connect to it. 1, 2, 3, 4, 5, 6. That's the board rate. I believe it's now on. Let's have a look. No, not default program. Device and printers. Windows is so slow. COM13. So now if I go COM13, we get a command prompt, and then I should be able to go A and see where that has triggered. Okay, we've got an issue with too many breakpoints. Let's remove some we don't need, both. We need that one there, we don't need that one there, we don't need that one there. And we'll keep that one there. So let's have a try again. Yep, so the MCU's responded, and now if I go VV we should get the version, and then if I go AO we should be able to then see that. Let's go run this command GPIO2 if pin is less than min pin. That's good. Pin C. Okay, so I see the issue. I've got it adding 2 up here, so pin equals pin plus 2, and then down here I have it pin equals IO pin equals pin minus 2, so IO pin is simply gonna be made pin. And we can actually move 2 lines, so what I'm going to do is remove, I'm going to comment these out for now. Nope, that I do want to be commented in. So what I'm doing currently is, and this is what is great about debugging, I'm converting it, adding 2, then down here I'm then removing 2 again. So it kind of gets a bit silly. So instead what I'm going to do is pin equals pin minus 2. That then makes it 0 again. So I just wanted to have this plus 2 up here. So I'm then going to just comment these out. And I can actually see I shouldn't have done that from the beginning. Just realign that one. Yep, so that's all done. And then I'm going to just do here IO pin equals pin. That means if I do need to change it anymore and have these separate, I can still, but we know that this is always going to be pretty much replicated throughout the code, so let's stop it and re-debug it. And go. Next I need to quickly make a reference sheet for me to know which pin number is which letter off the top of my head. bring this over to the screen now. So pin letter note A is number 2, B 3, and let's see if Google can calculate that. I want 2, 3, 4, 5, all the way to 25, 26, 27, yep. Let's see if it can do the alphabet bit as well. Nope, it can't. A, B, C, D. Nope, it can do numbers but it can't do the alphabet. There we are. So the traffic hat's got pins number 22, 23, 24, 22, 23, 24, U, V and W, so I should be able to now go through the command line. U, output. You can see Eclipse has triggered it. I'm going to just ignore Eclipse. Resume, you can resume. O. U is O, U1, U0. Let's just check. So U I have down as 22. Let's try V. V O 1 V0. So it's not fixed, it was still out 2 pins, I believe. Let's try S O S1. So still a couple of pins out. It's almost like it is still minusing it. Let's try. So if I send it U, so I know that U should be this, so pin equals pinch 20, 22, whereas that should be 24. So I need to change this. Why is it minus A? I'm gonna add 4 to it now and see how that works. Let's try step over 20, 24. And run. That looks right now. So if I do U1, we get nothing now. Development. So U should be 22. So why is this now not working either? +24. So this should be +2. And this is why we do debug. So 20 + 2, 22. Okay, so the next issue is our array of IO pins begins at 2, so then what it's doing is it's going along, and if I add a watch to GPIOs, and now if we go and have a look, GPIOs 24 is actually pin PB0, and if I go and have a look at what PB0 is mapped to, PB0 is mapped to 26, so it's actually beginning with -2 to begin with. So what we need to do is we'll add placeholders in for GPIO 1 and 2 for when we do add them. We'll add them up here because we know so these 2 pins that won't work, but they're just placeholders essentially. And then that keeps them there for when we do need them in the future. So let's re-debug it. And let's go run. Let's ignore the breakpoints for now, so then I can just go quick. Yay! And then once I hit the wrong command, so you can see now when I'm sending you, I am getting the green LED to light up. So we have now got that refixed. Let's try V, VO, V1, and W, WO, W1, and we are there. So at the moment we have this working. Well, let's see, should I try and quickly fix that issue in Python under Windows or not? I am just having a quick look at how it does it. Oh, I'm on master on the development, that's why. Okay, so I want to go char 0 plus all so A is that, let's go 0, 0 is underscore, So if I send this underscore, what does it translate it to? Is the question. It does not like underscore, nor any symbol really. So I believe that needs changing. Yeah, here we are. If it's lower and down. So let's try if it is greater than or lower than that. No. Oh, do we have an error or not? We might be working. So let's kick back in. Underscore. Okay, yep, so that's worked. So we have step over. We have -2 plus 2 equals 0. So that will now work. However, I might change what I've done because it's going to break compatibility with another bit of software. So let's have a look. So if I say what is seven, let's have a try at this method. 26 equals that. So the new min pin is 0. I say that instead of it being that, we go A to straightforward line. Let's try that. So I will now create, if I shift all of this down there, so our new reference is 0 GPIO 0, which is one of the hat pins, is A, and then 27 should be a straightforward line, and 26 should be a curly brace close, I believe. Looks like a curly brace close to me. If I get the right screen up. Oh no, curly brace open. So that's going to cause a not an issue. I'll set that to that. Let's go. So if I now want to turn on GPIO 24, it is Y. So if I then send on here, I'm using this to be able to calculate the Y O. Let's ignore the breakpoints for now. Y1, Y1, Y0, Y1. And now we have this other issue back again. So if we go and Y0, freeze that because I added that back in. 26, so it's actually pin equals that. Pin equals. I count this out and go back to, so what is Y? Y should be 24, so that should work now. Go debug stop. Yep, go Y0, Y1, Y0. If I go and attempt to turn on 27, bracket O. Well, I don't know yet until I run it through the Jenkins server, but that looks like it may work. So the next thing to do is run it through Jenkins, I believe. Yep, so that's all working. So it's now time to run it through Jenkins. So I set up I believe that's the, no, that's the wrong one. There we are, that's Jenkins. So this is a way of being able to test out your code automatically. You set up Jenkins with either the programs to run or the tests to run, and it will go through and run them. Jenkins has 2 programs at the moment. It's probably going to have more, where it goes ahead and checks and compares all of the GPIO pins against all the ones on the RTk.GPIO board. So I'm actually using a Raspberry Pi hooked up over a GPIO cable. So if I just, so I've got a Raspberry Pi here. This is a model B plus, I believe. Yep, B plus. A 40-way ribbon cable with some pins disconnected. They're power pins, because one neat trick, if you know how to do it, is you can have it where the Raspberry Pi, what's the neat trick? You can have it where the Raspberry Pi turns off the power to the USB ports, and it's quite handy if you need to remotely reset the board. So that's why they're disconnected, because otherwise they were powering it. So if I just hook this all up, that cable from there to there, and then once we get Jenkins going again, and there goes the webcam, so I just unplugged it. Great. There we are, that's the Raspberry Pi plugged in, ready to go. Let's turn off the webcam now then. Log into Jenkins and run a build. This should tell us whether our code is working or not. Nope, we've got failure. That's an issue with the serial port on it. Not an issue, really. Simple fix. This is actually going to take more fixing than I thought. But otherwise the code is there, it's just now getting Jenkins going again. So I'll post an update about that soon. That's all for now. Bye.